Okay, so this is clear, right? Okay, then from the Pythagorean identity, sine squared of the same angle plus cosine squared of the same angle is 1. You remember how to get these. If you divide both sides by sine squared, you get 1. If you divide both sides by cosine squared, you get the other. Okay, now these we did not prove. So here they are. Sine alpha cosine beta plus or minus. If this is plus, the first one is plus. If the second one, if it's minus, it's minus. So sine beta, cosine alpha. Then cosine alpha plus or minus beta is cosine alpha, cosine beta, but negative and plus. So plus goes with minus here, and minus goes with plus. Sine alpha, sine beta. Okay? And this one, the last one, tangent alpha plus or minus tangent beta over 1 minus plus tangent alpha tangent beta. So plus plus minus 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 plus. From here we proved sine twice alpha, cosine twice alpha, and tangent twice alpha of the double angle. And there is no problem. Once you remember these, all you have to do is just replace alpha and alpha. In other words, alpha plus alpha, you get this. Alpha plus alpha, you get this. Alpha plus alpha, you get this. So that's all I'm doing. So 2, I got your message. 2 sine alpha cosine beta. And we have 3 different ones for this. Cosine squared alpha minus sine squared alpha. And of course, if I change this into 1 minus sine squared, I get another identity. And if I change this into 1 minus cosine squared, I get another identity. So from here, we also have 2 cosine squared minus 1, or 1 minus 2 sine squared. Tangent, I get it from here. So it's 2 tangent alpha over 1 minus tangent squared. One last set is the half angle. Both are coming from this identity. So the sine squared alpha over 2 and the cosine squared alpha over 2. From here, I have 1 minus cosine alpha over 2 and 1 plus cosine alpha over 2. That's all I would like you to remember, especially these. Of course, if I have to take the square root, I will have plus or minus the square root, right? Of course, if I have to solve for sine squared, I will move cosine squared, take the square root from both sides, and have plus or minus. So should I guess that you want to start with reviewing trig? Is that what you wanted? Okay. So chapter 7 or 5 and 6. I'm on page 530. And that's a review for chapter 7. The super important here, and you will have a problem like this, is solving a trig equation. So, and of course identities. Identities and trig equations, and I will ask you either to find sine alpha over 2 or sine 2 alpha. So you will have a question like this, one like this, and an identity and an equation. Pretty much, this is what I would expect to see. So let's start with the trig equation, first of all. let's say 35. And this is 2 sine squared minus 5 sine x plus 2 equals 0. I will, in Canvas, I will post a list of problems that I would like you to review. And one more time, if you would like to come on Saturday, if you want, in this room from 1 to 3. Okay. So I'm asked to solve this trigonometric equation. What do I have to do first? So 2 sine squared minus 5 sine x plus 2 equals 0. Of course, I have to solve for sine x. Right. Good. So how do I factor this? You can say, I don't remember factoring. Let's assuming we don't remember factoring. How will you solve this? For sine first. So I'm saying let t be sine x. So the equation is 2t squared minus 5t plus 2 equals 0. I forgot factoring. There must be another way. What is the other way? Sure. So t equals negative b plus or minus b squared minus 4ac. 4 times 2 is 8 times 2 is 16. Divided by 4, or 2a, in other words. So 25 minus 16 is 9. When I take the square root, I get 3. So 5 plus or minus 3 divided by 4. So I have two options for t, which is sine x. 5 plus 3 is 8 divided by 4. I get 2. 5 minus 3, I get 2 divided by 4, 1/2. So then I have two equations. One equation is sine x equals 2, and the other equation is sine x equals 1/2. Any questions so far? Okay, how do I solve the equation sine x equals 2? Right. However, it cannot be. Why? Sine cannot be more than 1. No solutions. Perfect. So now I have the equation sine x equals 1/2. I need to go back to the unit circle because I know sine is positive in 2 quadrants. Which quadrants? Right, so I have to come up with 2 solutions. Infinitely many, actually, but 2 different ones. Now I have to go back to that little chart. Where is sine 1/2? 5 or 6 indeed, or 30 degrees. Excellent. So then this is the angle in question, and this is the 1/2 that I'm talking about. So there is another angle right here. So here the reference angle you already told me. What will be the reference angle here? It's a silly question. Of course, it has to be the same because this is the height. This is sine of this angle, and sine of this angle is this. So then, what is the angle? The second one. So from here I have two options. X is pi over 6 plus 2 pi k. And x equals, yes, so I have pi minus pi over 6. Right? This is pi right here. But I have to go back pi over 6. So pi minus pi over 6 is okay, pi minus pi over 6. I need the least common denominator, which is 6. I multiply this one by 6. 6 pi minus pi is 5 pi. So 5 pi over 6 plus 2 pi k. Please review trig equations. Do we need another? Do we need another trig equation? Yes? Okay, very good. For example, 41. I let you choose if you want. Would you like to choose? They are on page 530, from 31 through 46. Some of them are more difficult than others. Any preference? 41. That's the one I was looking at. 41. Tangent to the third plus tangent squared minus 3 tangent x minus 3 equals 0. When I see a trig function, a trig equation like this, and I see that when I get an equation like this and I see that a trig function is a ratio, you can say, but they're all ratios. Right, even sine is a ratio, opposite over the hypotenuse, and cosine. But tangent is a ratio of two functions. And there will be a major problem if the function in the denominator would be 0. So I have to state this restriction that cosine x cannot be 0. Whatever I get as solutions, I have to make sure that cosine is not 0, because I cannot accept a solution that makes tangent undefined. So now I think of, well, I see 4 terms. What do I always do with 4 terms? Always. Thank you. So from the first 2, what will I factor out? So tangent squared x. What is left in parentheses? Tangent x plus 1. What should come out from the other 2? I don't even look. From in here, I have to copy it first. You're right. What do I have to copy here? Exactly. Otherwise, I cannot continue. And now I look, and yes, it's -3. Now, this becomes the common factor that comes out. So tangent x plus 1, and in parentheses, tangent squared minus 3 is 0. From the beginning, what is the degree of this equation in tangent? It's not polynomial. I shouldn't even talk about the degree, but if we want to talk about the degree in tangent, what will you say? Degree is of this. 3. So how many solutions I'm looking for? 3. Perfect. Okay. So I see for now, I see 2 options. Tangent x to be -1, and I see tangent squared x equals 3. That will give me 2 more solutions once I take the square root. So I have tangent x equals plus or minus the square root of 3, and I have tangent x equals -1. That's good, but it's far from over, because I only found tangent. I did not find the angle. So all this work was for tangent. Now I need the angle. So how do I determine the angle? Well, tangent x equals -1. I have to go back to the unit circle. Tangent is negative when sine and cosine have opposite signs. Where is tangent negative? Exactly. So I need an angle in the second quadrant, and I need this angle in the fourth quadrant. Now I have to ask myself, tangent of what angle is 1? And I know 3 options. I'm told specifically, I'm asked specifically not to remember tangent, but I know there are 3 options. One option is 1/2 over the square root of 3/2. The second option is the square root of 2/2 over the square root of 2/2. And the third option is the square root of 3/2 over 1/2. Of course. It must be pi/4. So then, this is one angle, and this is the other. Perfect. Now what? I have to decide, what is this? What is this angle? And I have to find this angle. So tangent x equals -1 gives us 2 different angles. plus pi k, because tangent is a function with a period of pi, not 2 pi. Only two functions have period pi, tangent and cotangent. Everything else has period of 2 pi. So how do I count? I know the reference angle is pi over 4. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Now I have these two. So tangent x equals the square root of 3. Where is tangent positive? Where sine and cosine have the same sign. Now, I don't know which angle is this, because I was specifically told not to waste my time with tangent, but I know there are only three options, and it's not this, because that is 1. So I need to have the square root of 3 in the numerator, and the denominator will disappear. 1 over 2 over the square root of 3 over 2 will be the square root of 3 over 3. But this one is the square root of 3 over 2. When I flip 2 over 1, the denominator will go away. So it's this, which is pi over 3. So then I have, this is pi over 3. This is one angle, and this is the other. The reference angle is pi over 3 in both. You can make this next to the chart. So once you start the final exam, I would put this chart in so I don't have to, I don't know. And if you write it like this, then you'll know these are tangents, and you'll know that this will be the square root of 3 over 3, and this will be the square root of 3. Okay, so then tangent x equals the square root of 3. I have two options. What are the options? So yes, because I have pi plus pi over 3, which is indeed 4 pi over 3. I have one more. Tangent x equals negative the square root of 3. But I know it's going to be an angle here and an angle here. And with pi over 3, there's the reference angle. So what is the first angle that ends or has a terminal side in the second quadrant? So x equals 2 pi over 3 plus pi k, and x equals 2 pi minus pi over 3. 2 pi minus pi over 3, the least common denominator is 3. I multiply that by 3. 3 times 2 is 6. 6 minus 1 is? A lot of work on this problem. Now I have to make sure that cosine is not 0. But where is cosine 0? Remember, cosine is the first coordinate. It's the x-axis. So here's the unit circle, right? Here, x is 1. Cosine is 1. Here, x is negative 1. Cosine is negative 1. Right. Did we get any pi over 2 and 3 pi over 2 in these solutions? No. So we are safe. But we have to check. We have to make sure that. So all of them are accepted. These, and these. Yes, they can be condensed. Don't worry about that, though. These are the correct solutions. Can we move on to something else? Are we okay with this? Okay. Should we look at an identity? Prove an identity? Yes? Okay, very good. So please choose from 1 to 24. If not, I will. Let's look at 19. we're asked to show that cosine x over 2 minus sine x over 2, everything squared, is 1 minus sine x. When it comes to identities, when I look at this equation, of course I'm going to, this identity, of course I'm going to start on the left-hand side, but I don't know where I'm going to get or how I'm going to get here. Sometimes I can see step 2 and 3, but sometimes I cannot. So what I'm asking you to do when you have to prove an identity is start with a more complicated side and do something to it. You will always find something to do to it. So if I start with the left-hand side, which is cosine x over 2 minus sine x over 2 squared, at least I will square and see what happens, right? So while talking, now I see how I will get there. How many terms will I write when I square a binomial? Yes, first term squared. Cosine squared minus 2 plus sine squared. Now I'm looking at these three terms, and I should be able to identify something. What? Exactly. So cosine squared of an angle plus sine squared of that same angle is 1. Now I know what this is. Because there is a formula or an identity that I know has 2 sine cosine. There is only one that has 2 sine cosine. Which one? Sine x in this case. So minus sine x. And it's done. Right hand side. So sine twice x is 2 sine x cosine x, but sine x is 2 sine x over 2 cosine x over 2, and I use the same formula. I just changed 2x into x. Therefore, I had to change x into x over 2. For example, problems 67 and 68 and 69 and 70 are super important, but not for the next course, I have to be honest. It's for the following one, which is Calc 2. They're very important. So let's look at one of them. Please choose 67, 68, 69, 70. Okay. 68 on 531. Sine of tangent inverse of 3/4 plus cosine inverse of 5 over 13. How do I address this? Excellent. So this is alpha, this is beta. So I'm really asked to find sine alpha plus beta. I'm going to write my formula right here. Sine alpha plus beta is sine alpha cosine beta plus sine beta cosine alpha. So I need to determine 4 numbers and put them in, and then I'm done. But I'm far from that. I have to write alpha equals tangent inverse of 3/4, and now I have to apply tangent, so tangent here and tangent here. So then I have from here that tangent alpha equals 3/4. I have to draw that triangle. I have to draw an acute alpha. I have to identify that this is 3 and this is 4. So this squared plus this squared will give us this squared. But 9 squared plus 16, I'm sorry, 9 plus 16 is 25. The square root of 25 will be 5. So I already have 2 of those values, of those 4 numbers. So I can identify sine alpha now. How much is sine alpha? Very good. And I can identify cosine alpha. That's it. Now I have to address the same thing, or do the same thing to beta. So I have beta equals cosine inverse of 5 over 13. Now what? So then I have from here that beta equals cosine beta equals 5 over 13. So I have to draw a right triangle with an acute angle beta, and I have to identify that this is 5 and this is 13. Now, in order to determine this, I have to take the square root from 13 squared minus 5 squared, which is 25. So this is 169 minus 25, which is 144. I know that this must be 12. Knowing that that's 12, consequently, I have the other 2 numbers. Sine beta. Very good. Cosine beta. I already have that. So now I can put everything together. I have 3 over 5 times 5 over 13 plus 12 over 13 times 4 over 5. So I'll calculate simplifying 3 over 13 and plus 48 divided by, I should have not simplified because now I have to multiply. So I'm going to keep it. So 15 over 65 plus 48 over 65, is it? So I get 4, 5, is it 63 over 65?
Yeah.
Okay. $70 will be the same thing, it's just that in 70 you don't have numbers. Okay. I'd like to do one more problem here, maybe some more problem, like 72. Like find the exact value of the expression. Let's say problem 52. So sine 5 pi over 12. Find the exact value of this expression. First of all, I have no idea what 5 pi over 12 is. So I'm going to either grab my calculator and multiply 5 by 180 and divide by 12 and see what I have. So this is basically 75 degrees. Now this makes the problem very easy because I know how to get a 75. Now I go back to the formula, which is sine pi over 4 cosine pi over 6 plus sine pi over 6 cosine pi over 4. I have that little chart. I know that this and this must be the same. The same with what? And we're talking about sine pi over 6, which is the first angle. So this is 1/2. This must be the other one. I will factor out this, which is the square root of 2 over 4, and I'm left with the square root of 3 plus 1. Any questions?
I think I was extremely confused about what you just said.
Because I have the square root of 2 over 4 in both products. The square root of 2 over 4, and then I have left the square root of 3 plus 1.
I got it. Okay.
Okay, I'd like to look at least part A of this problem. A 380-foot tall building supports a 40-foot communication tower. So this is the building of 380, and this is the telecommunication tower of 40. As the driver approaches the building, the viewing angle, which is theta right here, he's looking to directly towards the communication tower. As a function of, the viewing angle theta of the tower changes. Express the viewing angle theta as a function of the distance x between the driver and the building. I'm going to copy the figure. So, and this is problem 72. Express the viewing angle theta as a function of x. Any suggestions? Any ideas? That theta is not in a right triangle, but I do have two right triangles in there that I could look at. This and this. And I could say something about this, or write something about this, and write something about this. Any suggestions? I'm going to call this alpha. In the smaller triangle. Can you give me a trig function that involves, of course, the opposite and x? Which angle, which trig function of alpha will involve 380 and x? Of course. So can anyone give us tangent alpha? Good. Now we're going to call what? What do you think I'm going to do next? Excellent. So now what will I do with alpha and beta? Because theta is the key. Alpha and beta, we just created them.
Tangent beta minus tangent alpha.
Right, but so the idea is that theta equals beta minus alpha. Would you agree? But that does not mean anything about tangent. So in order to determine beta, I have to do something to both sides and then put it here. Exactly. So then theta will be tangent inverse of 420 over x minus alpha will be exactly of 380 over x. And this is indeed a function of x and nothing else. So we determine the function that is theta of x that has only x in it and nothing else. Okay. One other type of problem that you may see on the test is, let's say, I can't find one here. Find the angles, write this, write that, solve this, solve that. No, I can't see, I don't find a problem in the review. Was that part of chapter 5 or 6? No, it's part of chapter 7, but I don't see a problem here. For example, given sine x, sine alpha equals, well, I'm just going to make it up, 3/5. Find sine x over 2. And for theta in the second quadrant. Or find sine 2x. So I may ask you this. Given something, some trig function value, find sine x over 2 or find sine 2x. How do I find this or this? What do I have to find first for sure? Cosine, exactly. Why? Because I know this formula is plus or minus the square root of 1 minus cosine over 2. And this formula is 2 sine x cosine x. No matter what I do, I have to have cosine. Theta is in the second quadrant. Sine is 3/5. What will be cosine? As I know, is plus or minus the square root of 1 minus sine squared. However, for theta in the second quadrant is not plus or minus, but only minus. So cosine x equals negative 1 minus, I square 3/5, 9 over 25, and I take the square root, 16, so negative 4 over 5. Now the problem is solved. I have sine 2x in a blink, and I have sine x over 2 in a blink, and since sine is in the second quadrant, half of it will be either in the second, which is not going to happen, in the first quadrant, so it's going to be positive. So then I have sine x over 2 equals the square root of 1 minus 4/5 minus negative 4/5, so it's 1 plus 4/5 over 2. So 5 plus 4 is 9 over 10, so the square root of 9 over 10. And yes, it's 3, the square root of 10 divided by 10. And sine 2x is exactly what I have, 2 times 3/5 and times negative 4/5. So negative 24 over 25. So you may see something like this. I can't think of anything else from chapter 7. Now going back to chapters 5 and 6. Law of sines and law of cosines. I'm looking at the review in chapter 6. Yes, for example, problem 79. Find the distance between points A and B, this is A and this is B, on opposite sides of a lake from the information shown. So 79 on 486. On 486. So here is B, A, C, 42 degrees, 3.2 miles, 5.6 miles, and this is the unknown. So we know BC, we know AC, we know the angle between, or angle C. I have two options. Law of sines is sine A over A equals, very good, equals, good, that's one option. The second option is A squared equals B squared plus C squared times cosine A, because it's law of cosines. So think for a moment and tell me which one is the best to apply here. Say it again. I would apply the second one. Here's why. So if I'm asked to find this, I'm asking myself, do I have the rest? And the answer is yes. I have B squared, I have C squared, so then I know 2BC, and I have cosine A. So I would write that x squared equals 5.6 squared plus 3.2 squared minus 2 times 5.6 times 3.2 times cosine 42. Whatever I get, I'll take the square root from it. So 5.6 squared plus 3.2 squared minus 2 times 5.6 times 3.2 times cosine 42. If my calculator is not in degrees, I'll mess up completely. So I'm going to look in mode. It is. Okay. So then I click enter. And whatever answer I get, second and the square root from the previous answer. So it's 3.87 miles. So x approximately 3.87 miles. Okay. On page 485, let's say 48. Write the first expression in terms of the second. So we are asked to write secant theta in terms of sine, only with sine theta, for theta in the third quadrant. What is the definition of sine theta? I'm sorry, secant theta. Now, cosine theta in the third quadrant, is it positive or negative? Negative. I want to represent cosine in terms of sine. What will I write? Just sine squared. Because sine squared plus cosine squared equals 1. This is it. As I mentioned, I will post problems to look at, and I'll choose odd number problems so you have the answer in the back, similar to the problems you'll see on the test, on the final exam. Okay, what should we go back to? That absolute value, you will have the absolute value, and you will have factoring. Should we go back to log, exponential?
There was one on the test that,
Yes.
the exact problem, but like the type of problems, I thought I was okay with, apparently I got wrong. We were adding, the problem was 2 to the x minus 2 power, x minus 2. That equals 16 to the 3x plus 5.
Okay, here's what I recommend. When you have an exponential equation, always think or check whether you can present both sides with the same base. You will see in the solutions, because I know the majority of the students go ahead and apply log, which is fine. It's not incorrect, but it's easier if you don't apply log as long as both sides can be presented with the same base. So you'll see in the solutions I presented both, with applying log to both sides, and maybe I made a mistake and maybe you didn't have a mistake there. I'll take a look at the end. So what I recommend is this. Then you have 2 to x minus 2, and you copy the base, but you have to multiply here. 4 distributed to 3x, and 4 distributed to 5. So now remember, I don't want you ever to say, oh, you simplify 2, or we divide by 2. No, we don't. We are saying this. 2 numbers are equal, and they have the same base. So if they have the same base and they are equal, what has to happen to their exponents? Right. So then I have to write x minus 2 equals 12x plus 20. I move this here, negative 11x. I move this here, 22. X equals negative 2.
Okay, I was just wrong. I had the basic idea, except I did 2 to the 4th on the left side, x minus 2, and raised all that to the 4th power, so I had like 4x minus 8.
Oh, okay. But is it clear now?
Yeah, that's clear.
Okay, very good.
So I just written one down.
Very good. So what were we doing next? What did you have in mind?
Can we do the absolute value?
Yes. So just make one up. Anything you want. I'll make one up. Let's say 1 minus 4x. And you make up the other one. 2x minus 4. Good. So I take 1 minus 4x and 2 minus 4 aside. I have to come up with their expressions, simplified with no absolute value. So I have two options. 1 minus 4x if
X is bigger than.
not yet. You're way ahead of me. If one, we have to write this because otherwise it is possible that we make a mistake because I have to move 4x to the other side and it will be x less than or equal to 1/4. So please do not assume. Write it first. And then negative 1 plus 4x, you don't have to solve the other inequality. Well, what will be the other inequality? If one of them is less than or equal to 1/4, the other one must be greater than 1/4. This happens, this twist happens because this is a negative slope. This is a positive slope, right? So 2x minus 4, this is, I can write it, go quickly, and this is x greater than or equal to 2. Negative 2x plus 4 for x less than 2. But be careful with the one that is twisted in the sense that it has a negative leading coefficient. Do not assume. Write it first, look at it, and say, oh, okay, I have to move 4x to this side, and when I look from this side, I have 4x less than or equal to 1. or x less than or equal to 1/4.
But after you only switch signs and you divide by negative.
I'm not, I wasn't switching, but let's do that, what you just said. So if I have to solve the inequality,
I see what you did.
I have negative 4x greater or equal to negative 1. I divide by negative 1, so I do have to do this, right? So x is less than or equal to 1/4. Better?
Yeah, no, before you were just looking at it a different way. That's what so I thought you switched sides.
Yeah, so I didn't want to, so I moved it to this side, and when I look from this side, I have 4x less than or equal to 1, which means x less than or equal to 1/4. Okay, perfect. So now, if you want to choose to use this chart, I think it's very useful. But of course, there are other methods, and I'm fine. I'm happy if you are happy with any method. So the absolute value of 1 minus 4x, the absolute value of 2x minus 4, and the last one, which is 1 minus 4x minus 2x minus 4. Which numbers go in the chart? Obviously,
Before,
and
two.
yes. Good. And now I just summarize what I have. So this one says, the absolute value can be replaced by 1 minus 4x to the left of 1/4. So 1 minus 4x, but then negative 1 plus 4x and negative 1 plus 4x. Now, the absolute value 2x minus 4 can be replaced by 2x minus 4 to the right of 2. And the other one will be negative 2x plus 4, negative 2x plus 4. Now I know what I have to do, but careful because there's a subtraction there. So from the first, I subtract the second. So what do I have here? 1 minus 4x plus 2x minus 4. So this is negative 2x minus 3. Now here, negative 1 plus 4x plus 2x minus 4, which is 6x minus 5. And the last one, negative 1 plus 4x minus 2x plus 4, 2x plus 3. Now this is not enough, right? Because I have to write the final answer. The final answer is this minus this, and I have to show 3 options. So it was 1 minus 4x and 2x minus 4. So I have negative 2x minus 3 if, 6x minus 5 if, and 2x plus 3 if. If what?
First one is x is less than 1/4.
Now 1/4 x 2 and x greater than 2. Of course you can play with the equal symbol, but only once. Once at 2 and once at 1/4. We will have a problem like this. There is no secret. You will have a problem like this. Okay. The other one that I wanted to talk about is simplifying by factoring. Like a problem like this. So 2, quantity x minus 1 raised to negative 1/2. Then quantity 2x plus 1 squared minus 4. Quantity x minus 1 raised to 1/2. And 2x plus 1 to the third. No secret, a problem like this will be on the test. And yes, we will have to be, the requirement here will be simplify by factoring. What will I factor out? Say it again. Yes, first of all, 2. 2 is one common factor. X minus 1 is a common factor, and 2x plus 1 is a common factor. However, we must discuss exponents. So what will be the exponent for x minus 1? Of course, the smallest. What will be the exponent for 2x plus 1? Allow me to change this into 3 and this into 2. Sorry about that. So it's balanced. You'll see in a moment why. Very good. So the power for 2x plus 1 is 2. Good. What is left from the first term? Yes, so just 2x plus 1 minus. What is left from the second term? Obviously a 2, for sure. Now 2x plus 1 squared is out. From power 1/2, I must subtract power negative 1/2. So from 1/2, I subtract negative 1/2. So this is 1. So x minus 1. So then I will put this in the denominator. So 2x plus 1 squared over x minus 1 to 1/2. And I have to simplify inside. So I have 2x plus 1 minus 2x and plus 2. It happens that these two go away. I have 2 plus 1 is 3 multiplied by 2 outside. So 6, 2x plus 1 squared over x minus 1 to 1/2. There is no secret you'll have a problem like that. What about graphing polynomials? Graphing rational functions?
I'm sorry, 1 second.
Yes.
Can you show how you went from the step, that step to the bottom?
This has a negative exponent. That's why it goes to the denominator. So this is a 2, and this is 2x plus 1 squared, 2x plus 1 minus 2x plus 2. 2x minus 2x go away. 1 plus 2 is 3. 2 times this times 3 is 2 times 3 times this, which is 6. 2x plus 1 squared over x minus 1 to 1/2. Better?
Yeah.
Good. We have about a half an hour left, so I want to use it efficiently. So rational functions, graphing, polynomial functions, logarithmic equations, which we did one. We did exponential equations. Logarithmic equations, word problems with log and exponential, quadratic functions, transformations, one-to-one functions. What would you like me to do right now?
Is the circle graph the ellipse?
Yes,
And the line?
yes, and I'll give you the formulas.
Can we do one like that?
Yes, of course. Would you like to go back to the problem from the test?
Sure.
Okay, I do. I printed out several. Actually, what happened was the copy center made me more copies than I needed. So if you want, I can give you. I have 5 copies. I only have 5. I don't have 6. So you don't have to print them out, because I was asking you to print out and retake the test at home several times. So I have 5 copies. Anyone interested? But I don't have 6. I can give you your stack. Yes? This is the last test. Last test. Tony? Last test. Okay. I have one more.
It's the one you just read.
Yes. I know you don't need it. I'll give it to you in a minute after I copy the problem. Yes, and this is a very good idea. Thank you for asking that, Sarah, because I saw in some tests, I don't know if it was just one or more than one. When you have to factor, you have to add and subtract inside. You cannot, so for example, for x squared, this is a perfect example. For x squared, I don't have to factor out anything. So the middle coefficient is 20. I divide 20 by 2. I get 10. I square 10 and I get 100. In this case, since I have 100 in the problem, I am going to use it. So I'm going to condense these three into x plus 10 squared. This is gone, this is gone, this is gone. All three of them are here. But now, since I have to factor out 4 first and write y squared minus 10y equals 0, I saw in one of your tests, or maybe two, you added 25 here and subtracted 25. You cannot do that outside of parentheses because of this. Okay? So the equation becomes x plus 10 squared plus 4 y squared minus 10y. 10 divided by 2 is 5, or negative 10 divided by 2 is negative 5. Negative 5 squared is 25. 25, I have to add 25 and subtract 25 inside parentheses, not outside. So now in brackets, I have two things. So I have x plus 10 squared plus 4, and in brackets I have y minus 5 squared minus 25 equals 0. It must be inside because of this number out here. So that's why we have x plus 10 squared plus 4 times this, but I have to leave it alone. It has to stay outside. I cannot put it in. And now 4 times negative 25 is negative 100. Now I move 100 to the other side. Something that has a number outside other than 1 cannot be a circle. It could have been a circle without this number in front. But if it has a number in front, either in front of x, something with x squared and something to it, or both, it can never be a circle. What do I have to do then at this step? Divide by 100. I have no choice. So this is x plus 10, everything squared over 100, plus 4, y minus 5 squared over 100, and I have to simplify. And I'll simplify, and I get 25. So x plus 10 squared over 100 plus y minus 5 squared over 25 is 1, which makes it clearly an ellipse. So now what is the center of the ellipse? Because it's not 0, 0. So it will be negative 10, right? Negative 10, positive 5. Now a is the square root of this, which will be 10, and b is the square root of this, which will be 5. So the ellipse will be 10, 10, or negative 10, 10, we'll see in a moment, and 5, 5. Okay, so but I have to graph the center first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. So here's the center. And from here I have negative 10, 10, 10, 10 to this each side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5. And this was 5. So So a problem like this will be on the test, and this is very important to understand or remember that you cannot, if there is a factor outside, you cannot add and subtract outside of that group. It has to be inside, and then you have to remember to distribute in here and in here. Okay. Graphing. Anything you would like to go back to? Any graphing? Polynomials, rational functions, quadratic functions. Is there anything that you can think of right away?
We do exponential logarithmic graph.
Yes. So let's make up any of them or both. Should I make one up?
Yeah, that's right.
Okay, so f of x, let's say, is log base 2 of x minus 2 plus 4. I'm asked to graph it, find the domain, find the range, asymptotes. On a function like this, even if I'm not asked to use transformations, here's what I would do. I know that the base function here is base 2 of x. Then is log base 2 of x minus 2, which moves the graph to the right 2. And then log base 2 of x minus 2 plus 4, which will shift the graph up. First, I will find the domain. And I know that log is a function with problems. It's not like exponential or polynomial functions. I don't even have to think about the domain. Nice. No, this function requires positive here. So then x minus 2 must be greater than 0. So the domain, I have to make sure that is 2 to infinity, no matter what I graph. So when I graph this function, I will say, well, if that's the case, I know how it looks. This must be the vertical asymptote.